I am really getting tired of claims that say that scientists are finding the signs of life on other planets. Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
Yeah, my co-host Rich Gear here. We got an out of this world show tonight, right, Doug?
Yeah, we're going to investigate the claims that Curiosity Rover on Mars is finding evidence for life. And so what I'm going to do is to try to ferret out exactly what they are finding in their samples and see if that actually matches what we understand as being precursors for life.
Okay.
So I was looking at this. I got a message from a service that I subscribe to called 1440, and it's based upon the uh, date of when the printing press was invented.
Oh,
Uh,
Gutenberg, the Gutenberg printing press was that back in the.
Gutenberg printing press, and it's supposed to be a fairly straightforward indicator of they're trying to be fair and unbiased in what they're reporting. And so I kind of like this little service that I'm getting. But
Okay.
it referred to this. Sometimes I see some of these evolutionary claims pop up on this, and I decided, well, I'm going to follow up on this, and it actually makes a good topic for a TV show. So this one I've seen a number of different times of from where they are the Curiosity rover actually first reported on different things they found in 2013. And the question is, what exactly did they discover? Well, the article that they referenced was fairly vague with that. I asked them, well, show me the chemical formulas for each of these compounds that they found. The first thing that they found were long-chain hydrocarbons. They're alkanes. And basically, if you take a look at it, the first one is decane, the second one is undecane, and the third is dodecane. And
What is
yeah,
that? What is that, Doug?
well, have you ever heard of octane?
Yeah. Okay.
Okay, octane is a eight-chained hydrocarbon, and it's just basically a bunch of carbon atoms
Well,
strung together
decade
with
is a
hydrogen.
10 is a 10 is it 10?
10, and then 11 and 12.
10,
And
11, and
so
12. Okay.
as you get in the longer chains of hydrocarbons, you get closer to being waxy type of
Okay.
stuff, and so you get from go from gases to liquids to oils to sort of waxy type of solids.
So, Doug, what does this have to do with life? I mean, I don't understand. Are hydrocarbons linked to living molecules or something, or what? Why do they say this is a precursor to life, or that this shows life on Mars, or or am I getting ahead of myself here? I'm just trying to follow you here.
Well, that's what I'm wondering myself.
Okay.
So the question is, what on earth does this have to do with finding life? Well, they say probably billions of years ago is when the signs of life were on Mars, and once it was a watery planet, and you find signs of floating on Mars, but there's very much little water left on Mars, and
You
so.
know, Doug, is there really is there any water on Mars? There might be some icy things, but I don't even know if there's real is there I don't have a problem with water being on Mars.
Mhm.
But and I've talked to you earlier today about that. We talked about it on our show before. I find it very remarkable that these same people who are trying to find water on other planets because water is needed for life. They on a desert planet like Mars, basically sterile and desert, they believe was covered in water. Yet they have a hard time believing that a worldwide flood covered our planet, when we have a planet that at present is still three-quarters covered in water and three-quarters covered in sedimentary rock, which is formed by water process, laying out by water action. So I'm going 90% of the surface is either covered in water or sediment that was laid down by water. So, and they have a hard time believing in Noah's flood. But this part in Mars, as we look behind me, I mean, and you're behind you, they had no problem ascertaining at some point that this was a planet covered by water. I think there's a really amazing double standard, or it's a really disconnect to me that happens with a lot of these guys. They try to show you how water was on this planet, and then on the other hand, they try to show you how there's never a flood on our planet. I don't, it's a non-starter for me, but apparently we're a non-starter for them. But so I guess it's a mutual non-starter. But I don't get it at all. When I look at Mars, it's sterile, it's desert. Is there any signs of water on there, Doug? Do you know? Have they found water on Mars?
Not very
Anything?
much. Well, if there's an ice cap, there's probably water in that, but
Yeah,
uh,
but is the ice cap water, or is it like on
carbon
Uranus?
dioxide, yeah,
Yeah, it could be carbon dioxide. I don't know what it's made out of. I don't know if it's
dry ice
it's
maybe.
too, yeah, dry ice, and so it's not the same as water anyway. I've
So
never been able to get an answer to that. Have you?
I
What kind
haven't.
of,
Now, the interesting thing also is that I was trying to find out, well, what actually did they find? And I said, is there any evidence of amino acids? And so
okay,
I was looking through the article and it didn't talk about it. It just said they were finding signs of life, living molecules. And so then I said, well, I'm going to ask the artificial intelligence. Did the Curiosity rover find any amino acids in their samples found on Mars? And it says no, they didn't find any amino acids. And
so
so
no amino acid. Check one thing off. Okay,
yeah,
all right.
okay. And then I asked, well, what about guanine, cytosine, thymine, adenine, the nucleotides that make up DNA? And I asked them, did they find any of those?
Yeah.
No, they haven't found any of
So
those.
check
Okay.
number two. No nucleotides.
No
Okay.
nucleotides. What they did find was a nitrogen heterocycle, which means a cyclic hydrocarbon that had nitrogen in it. Well, that sort of resembles a purine or pyrimidine that makes up the the guanine, cytosine, adenine, and thymines.
Okay.
So those are all nitrogen-containing cyclic hydrocarbons. But
That seems like a
they found
remarkably big leap to me, Doug.
so this was the big wonderful discovery that they made was that they found a nitrogen heterocycle that was unspecified. I asked the AI what is the chemical formula for this, and they didn't reveal it. And so there's nothing in the literature that tells us what the nitrogen heterocycle is. Now,
Okay.
what else did they find? Well, they found methane, which is the simplest hydrocarbon that's out there. They found nitric oxide, as that's supposed to mean something that there may be life coming about on
Why
Mars.
would that mean life, Doug? Can you give me a why would that mean life or a precursor to life anyway? Is that something necessary for life to work or what? I
So
don't know.
basically, what you have, this is from the Nature article. It says this: there is no evidence to suggest that the fixed nitrogen molecules found by the team were created by life. The surface of Mars is inhospitable to known forms of life. Instead,
Okay.
the team thinks the nitrates are ancient and likely came from non-biological processes like meteorite impacts and lightning on Mars'
Oh
distant
boy.
past.
Okay.
So this is the old Miller-Urey spark
Oh yeah. I see.
hypothesis that takes simple compounds and makes nitrogen-containing molecules out of them. Well, that doesn't lead very far, as what we've discussed in many years past of what it takes to form life. And so
So
I think what they need to establish is, first of all, before you have any kinds of life, you're going to have something that takes the light from the sun and fixes it into a process that contains living thermodynamic processes, which is what will start up life. So you need plants. You need plants with
Yeah.
chlorophyll. You need the chlorophyll process that will create from carbon dioxide and these other compounds we find in the atmosphere to fix the life. And that's what we need on to before you start anything on Earth either. And so they're trying to figure out, well, how we're going to do this, figure out where the life is coming from Mars. So the headlines that you get that the Curiosity is finding evidence for life on Mars is really a lie. As the as Yul Brynner said in The King of I, it is a false lie.
It is a false lie. Wait, a false lie would be the truth, wouldn't it?
So anyway, and then the article goes on to say features resembling dry riverbeds and the discovery of minerals that only form the presence of liquid water suggests that Mars was more hospitable in the remote past. The Curiosity team found evidence that other ingredients needed for life, such as liquid water and organic matter, were present in Mars at the Curiosity site in the Gale Crater billions of years ago. So they
Oh,
don't find it
well,
now, but they find evidence that the water and organic matter might have been there billions of years ago.
you know what, Doug? This is interesting because when I was kid growing up, I used to love a lot of reading a lot of books about Edgar Rice Burroughs. He's the one that wrote the Tarzan books, but he also wrote a series called John Carter of Mars, and he had the same theory that Mars was kind of a dying planet, but this was like millennia of years ago, and somehow John Carter gets transported to the surface of Mars back in the past when there's all these civilizations up there. This reminds me remarkably like a science fiction story written in 1912 called A Princess of Mars by Edgar Rice Burroughs. I'm sorry, Doug, but this gets more fanciful every time you open up a thing. It seems more and more fanciful. But anyway, that's just my take on it as a kid loving those Mars books. But this looks like another fantasy to me, Doug, because dry riverbeds. I mean, as I said in my disclaimer in the front, I don't really have a problem that if in the past Mars could have had water on it. You and I have talked about the properties of water. That unless you already have a pre made structure or whatever that needs water, water is a destructive force, is it not, Doug? I mean, water is corrosive. I mean, you look at what happens to any like metal, it rusts. You look at things that happen in your own body when you get like free radicals and things. Yeah, each hot oxygen. I mean, water is a destructive force in that regard, and it prevents. You talk about the Miller-Urey experiment you talked about just a
Mm.
few minutes ago, a few seconds ago. Water would destroy any molecule combining, even with lightning. Correct, Doug? I mean, if there was water on the planet, this would really mitigate against life forming, unless it was already pre-made to accept water. Is that right? Am I correct on
That's
that?
right, yes. And the thing of it is that you have these lack of chemical foundations that you need for life that they're not finding. They find these hydrocarbons, these alkanes, which you find those in like cell walls, but
Okay.
lipids, those are 10 carbon, 11 carbon, 12 carbon atom chains of hydrocarbons, just like gas and oil and that thing. They're very let's suppose we give them. We're going to purify the amino acids to the left-handed kind, and
Oh,
then you have in the same uh, pond or whatever it is, these nucleotides and the correct three-dimensional structures that you need to that life uses. Well,
okay.
then what you need to do is to have a process that will take the amino acids and combine them together to form proteins, amino acid 1 and amino acid 2, and you remove a water molecule to form the peptide bond. And then in another chain, you have to remove another water molecule and form a peptide bond. The third one, the fourth one, you add, remove a water molecule and form the peptide bond.
Boy.
And then you got to figure out, well, you got to get rid of the water, otherwise it'll deform the peptide bond.
Ah, that's what we were talking about. I was talking about earlier. Yeah, the very thing needed for life is the very thing that stops it from starting. Unless
And
it,
so,
yeah.
but in life, when you actually have the created cell organism, you have this dynamic thing where you have the DNA codes for these proteins, and you have a process that removes the water molecule and forms a peptide bond. The DNA makes the messenger RNA. The DNA makes a messenger RNA, and then the messenger RNA is the code that the ribosome uses to form the chain of amino acids that form the protein. That mechanism is catalyzed by enzymes, and the
Okay.
enzymes are the product of the whole process. And so then you have transfer RNAs, which hook onto an amino acid, and that reads the code on the messenger RNA, and that travels through the ribosome one at a time, and it deposits the correct amino acid based upon the code that's reading from the messenger RNA.
You know
And
what, Doug? If it wasn't this wasn't made by divine power in the first place, it sounds like a Rube Goldberg machine. You know, and for us old people, it was a guy who used to make all these. Remember these all these weird gadgets and everything would move, move together to make it work and make some kind of weird machines. It was used to be very hilarious, but this is a complicated process, Doug. And I'm going. And they haven't found anything like this on Mars at all. There's nothing even anywhere remotely close to this stuff. It's
No,
amazing.
the major components that you need to start out with aren't there. So,
They're not there,
uh,
yeah. And
so
what
why
gets me,
is this
Doug,
claim?
is how and they continue. It's like these people will do anything to avoid the logical conclusion. Yes, it takes faith in some sense, but the logical, irreducible uh, deduction or induction, whatever it is, that there had to be a being that started it. There had to be somebody who started this whole process. We call him God, you know what I mean? Because that's and then we believe that he's actually transmitted and given his thoughts in a book called the Bible, which tells us how things work. But the science, when you try to get around that metaphysical, supernatural, you push that out of the way, you're left with foolish thoughts like this, Doug. Like life on Mars is to me we spend billions of dollars, a lot of money on this stuff. And I by the way, I'm in favor of space exploration. I like it. I think we can find cool things out there. It's amazing we can see stuff, but there it's like how many millions of dollars were spent on the SETI project and trying to find outer space aliens and trying to find life. Anything to get us away from the irresistible fact or the unassailable fact, in my mind, that man was made by God. He gave us a test. We failed it, but he gave us a redemptive power in Jesus Christ to come to him. And they will do anything to avoid those things because they have to then live for somebody beside themselves. Okay. And this is the thing. But you get a lot of people I think they get caught up in the weeds of it, and I'm a guy that likes going into the weeds, Doug, as you know, but they're in these weeds of all these trying to find how many angels can dance on the head of a pin. And the reality is, angels are spirit. They don't dance on heads of pins. It's a stupid argument. And they're trying to find life from something that was not created. They're trying to find something that's naturally creating a self-replicating molecule, whether it uses what life, whether you use amino acid. They're trying to find anything to show how it could have happened spontaneously without an intelligence behind it. To me, that's the epitome of hubris it's the epitome of the nature of man that does this kind of stuff. I mean, I like the idea of exploring Mars, to be honest with you, but we found out what we suspected all along. Life is only on planet Earth.
That's
And
right.
it's only on planet Earth because God made this little blue speck to be special in the entire created universe.
Now let me finish my illustration of the creation of proteins from being coded by DNA and RNA and the transfer RNA and messenger RNA and the ribosome. Because the
Visual.
last step is now you have a multitude of various kinds of proteins that are used to catalyze reactions. Now you need those for these other reactions that are going on, even the formation of DNA, you need DNA polymerase. DNA polymerase is the protein that encapsulates the DNA molecule as it's being formed so it doesn't screw up and scrunch up while it's forming this double helix. And so, in order to make that work, you need all these proteins with all these different codes from this code of DNA that codes for all these different proteins. And now they form this dance, and it's a chicken and egg problem. Which came first? The
Right.
proteins, which you all need for this, the RNA, which you need to, but you can't do it without the DNA, and you don't have the DNA because you don't have the proteins. There's all these interrelated products of life that has to be in place in order for life to exist. And
Yeah,
that's
again, unless everything works, nothing works. Is that what you're
right.
saying?
And beyond that, the proteins break down the food that is ingested by the organism. And so there has to be a mechanism to bring that food into the organism. And you have to have food that exists already from in the form of plants or chlorophyll type of things that fix the energy from the sun to perform the hydrocarbons and the things that are used in life.
And again, Doug, to reiterate, they have found nothing that remotely resembles what you've just talked about.
Right.
Correct?
What they have found were what they were looking for signs that was left by life billions of years ago,
No.
maybe. And so
Yeah.
this and so here I have an experiment that I would like the scientists to undertake to justify their claims. Take the chemicals that are found on the Mars surface, and since life is an on-off switch, either you have life or you don't.
Yeah.
You
Okay.
can't hide behind billions or millions of years. Form a living system such as a bacterium or a worm or an insect and show how it could have arisen from such chemical
Even a
spontaneity.
one-cell protoplasm might, if
Right.
you can even do that. I don't think you can do that.
And either either your life is operating or it is not. You know, it's not a something that gradually accumulates. The longer time you have, the more possibilities of it happening. No, that doesn't work. It's going to be something that's either on or off switch, and you can't hide behind millions of years.
Right.
And so, the chemistry doesn't allow it. You can't do it. I've tried it. It doesn't
Yeah.
work. I got burnt amino acids when I tried it, and and what I found was that I had this experiment set up wrong, and I can't do it in liquid solution because it adds water. It takes
Right.
the water molecule out, puts the water molecule back in, and it separates into individual amino acids. And so I was zonking glycine and alanine, and it did nothing because basically I was just
And you
instead
started with
of
something
trying.
that already was pre-existing. You already started with the two components, and it still didn't work.
Right, right. And so those are the two simplest amino acids. Of course,
Yeah.
nothing to burn. But in tryptophan and tyrosine, well, you got these long side chains, and the origin of those are really interesting to try to contemplate. But basically, I was burning those up and with my process and destroying them, and we got some results that non-biological goo is what I got.
So you want them to construct protein chains and DNA from your off-the-shelf chemicals to
Yeah,
kickstart living cells. Is that what you're saying?
right.
That
And
would be the experiment.
and so to find water on Mars or Europa or Titan or wherever else,
Yeah,
Enceladus or wherever else they are finding signs of liquid water, that is not going to help your origin of life
right.
scenarios. You need water to have life, and yet the water does not help the chemistry to formed the life in the first place. What do you think of that, Rich?
What do I think of that? Well, it's what I've always thought. I go, look, it's very clear to me from my obviously my bias, which is a biblical bias, that that this blue planet that we live on is the only planet, the only place that's going to be suitable for life, that has life in a physical environment. Which is kind of awe-inspiring when you think about Mars, Venus, Jupiter, Uranus. Neptune, all these things, they're just inner solar system. You see some of those planetarium things, and it keeps going out farther. God made all of this, and here we are, and he focuses on us.
Mm-hmm.
That is pretty awe-inspiring. Yes, it makes you feel small, but at the same time, it makes me feel special. It makes me feel amazing that he actually made us in his very image. Because we feel like I feel sometimes really, really small when you think about the huge entire cosmos, let alone Mars or anyplace else. But then at the same time, he made us in his very image and he gave us something the angels never had, a second chance. When man blew it, he gives us a second chance. So as far as the chemical things, we know, the chemistry, unless, like I say, unless everything works, nothing works. And I guess I'll kind of leave it with that. We kind of got any last thoughts, Doug?
Yeah, I think that this whole thing is a deliberate deception. Our government and people who are funding it are spending all this money to send these probes up to these different planets, and I kind of like that. But what they're finding, but the motivation behind it is to find evidence for life. Now, if Curiosity fails to find evidence for life, the mission
Yeah.
would be considered an abysmal failure. Justification for funding of missions like this and other missions to extraterrestrial planets with similar purpose would be called into question. And I think that this is a problem that we have in our science today is that much of the funding is coming from sources that do not want to find God. And so and if they don't find evidence for life, then they're not going to be, they're either going to be lied about or they're going to be something that is
They will miss the mark, Doug.
it's going to miss
So
the mark, yeah. And
amen to
so
that, Doug.
what a problem we have with that is something that I think we need to consider talking to our congressman or anything like that. Take a look at what you're actually finding out in space, report it correctly, and let the chips fall where they may.
Yep, I agree.
We'll see you next time on Revolution Against Evolution.
Amen.